Hey, good evening. Good evening. Hey, Jennifer, this is great.
Hey.
I see that people are joining us. I am Sandy Schoelles, and this is Jennifer Hynes, and we are Environmental Coffee House. And welcome. It is October, what is it? October 4th or
October 4th,
October
2020.
4th?
Did you ever think we'd make it this far? Holy crap.
It's unbelievable, unbelievable what's been going on. Oh my gosh. Personally, but in the world, it's like the news cycle, Jennifer, is it's insane. And if you keep up with
What a
it,
week it's been. I
yeah.
mean, if you think about it, this week we had the debate.
Eh,
We had Trump get coronavirus, which happened on Friday. So the debate was Tuesday. The coronavirus incident was on Friday. And it's just
mhm.
like kind of amazing.
It's kind of amazing. And then I had a
You know,
horrible week, but I'm not going to whine. We're not going to whine about our respective things that happened, but everybody, I'm back. I'm here. I'm looking at the chat. We've got a fun-filled kind of an ocean night. Uh
yeah, sure
yeah,
do.
ocean night.
We got a great show
I think
tonight.
so.
Sandy, would you like me to give the show
I
lineup
would.
and where
I
we're going?
sure would, Jennifer. Yes. Go
Okay.
for it.
All
Yes.
right. So the first thing, we're going to basically kind of like go back to school and do some pretty intensive dives.
Yeah.
This is an article that just recently came out in Climate and Capitalism, and it's called Triple Crisis in the Anthropocene Ocean, Part 1, Corrosive Seas, and then I will do Part 1, and
Mhm.
Sandy will do Part 2,
Mhm.
which I'm not sure exactly what it's called. I don't think I have actually
No no
the right link for
worries.
that one.
You will. I'll send it to
Okay.
you. I can do it right now while
Okay.
you're recapping.
Okay. And another thing that's kind of going on, you might notice we've got sort of a colorful globe behind us. The blob, the hot blob is back, and that's the hot blob anomaly in the Pacific Ocean. So this is one that just came out recently in sciencealert.com,
Mhm.
and it says the massive blob anomaly has our fingerprints all over it, study finds. And that
All
came out
over
less
it.
than a month ago, 24th of September, 2020. And then the next thing that we're going to cover is from the narwhal.
Mhm.
And it says smoke and acid where wildfires meet the ocean. So you can kind of see there's sort of a theme here. We're
Mhm.
talking about the ocean. This is really our ocean show. As
Yep. Got
forest
it all set
fires
up.
burn uncontrollably south of the U.S. border, the smoky skies over British Columbia hint at the suffocating life in an ocean growing increasingly acidic.
Mhm.
So that just came out on 16th of September, and that might be our show. But if we get to it, which would be a lot of material to get
Yeah.
through, the last one we'll do is also about the ocean down in the Southern Ocean. Antarctic sea ice may not cap carbon emissions as much as previously thought, keeping with our theme, something more than previously thought. So,
Yeah.
so anyway, Sandy, that's kind of where we're
Yep.
going today in this show.
Yeah.
So,
We're taking a deep dive. I think this publication is interesting, and I lost the about page, but I'm going to find it, and I wanted to start out with that. Jen's going to do the first article, but I wanted to just give you a little bit about this climate and capitalism, so we know the author is Ian Angus, and I just think it's interesting. It's an interesting one. There's so much good writing out there, Jennifer. You know,
there really
there really is. So I'm going to go to, I had the about of them. Darn it. Oh, here we are.
is.
It's compelling. Climate and Capitalism is an eco-socialist journal reflecting the viewpoint of ecological Marxism. It aims to promote, develop, and extend ecological Marxism, to inform, educate, and develop eco socialist movements, to help build movements and campaigns against capitalist destruction of the environment, to encourage and facilitate collaboration and exchanges of views among socialists and ecology activists. Now, we may not sit here and say, well, we are like, dyed in the wool socialists. We're in a capitalist system, but it's just interesting and compelling to see sometimes where the 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 big outlook is from, and that's what makes these writings like us. And remember when we found George Saccharlitis? I mean, he's just amazing.
Yeah.
So you find these writing, these pockets of writing, and I just love it. So Jen,
yeah. Want me
go
to take
for
it
it.
away, part one?
Take it away,
Okay,
Jen.
guys,
And I'm
fasten your seatbelts. It's going to be a bumpy ride. Okay. Triple crisis in the Anthropocene Ocean, Part 1, corrosive seas. Scientists call them a deadly trio. If acidification, oxygen loss, and overheating are not ended soon, a massive die-off of ocean life may be unstoppable. By Ian Angus. This is the introduction. It is impossible to overstate the importance of the ocean to life on Earth. Covering 71% of the planet's surface, it contains 97% of the world's surface water and is central to the great biogeochemical cycles that define the biosphere and make life possible. Marine plants generate half of the world's breathable oxygen. Millions of species of animals live in the ocean. Seafood is a primary source of protein for 3 billion people, and hundreds of millions work in the fishing industry. The ocean's metabolism, the constant flows and exchanges of energy and matter that have continued for hundreds of millions of years, is a vital part of the Earth system. As famed oceanographer Sylvia Earle writes, our fate and the oceans are inextricably intertwined. Our lives depend upon the living ocean, not just rocks and water, but stable, resilient, diverse living systems that hold the world in a steady course favorable to humankind. The living ocean drives planetary chemistry, governs climate and weather, and otherwise provides the cornerstone of life support system for all creatures on our planet, from the deep sea starfish to desert sagebrush. If the sea is sick, we'll feel it. If it dies, we die. The future and the state of the oceans are one. Our future and the state of the oceans are one.
R1.
Heavy stuff,
R1. It is
right?
heavy stuff. Yeah, and who's
Yeah.
talking about it? We are. Who
Yeah.
else is? Wow. They are.
Yeah.
Climate and capitalism
Yeah.
is.
Yeah, thank God. This is a really good article. We'll
Yeah.
just continue.
Yes.
See if we can get through this material.
Okay.
The living ocean is now being disrupted on a massive scale. It has changed before, but never since an asteroid killed the dinosaurs as rapidly as today. The changes are major elements of planetary transition, of the conditions that have prevailed since the last ice age ended, toward a profoundly different biosphere, from the Holocene to the Anthropocene. We are entering an unknown territory of marine ecosystem change. The implications for the ocean, and thus for all human beings, are huge. Most popular accounts of the relationship between the ocean and the climate change focus on melting ice and rising sea levels, and indeed, those are critical issues. Greenland alone loses over 280 billion metric tons of ice a year, enough to cause measurable changes in the strength of the island's gravity. At present rates, by 2100, the combination of global glacial melting and thermal water expansion will flood coastal areas where over 630 million people live today. That's a lot. Well over 1 billion people live in areas that will be hit by storm surges, made bigger and more destructive by warmer seawater. Rapid action to slash greenhouse gas emissions would be fully justified even if rising seas were the only expected result of global warming. Devastating as sea level rise will be, however, more serious long term damage to the Earth system is being driven by what biogeochemist Nicholas Gruber calls a triple whammy of stresses on the ocean caused by the growing rift in the Earth's carbon metabolism. In the coming decades and centuries, the Earth's biogeochemical biogeochemical cycles and ecosystems will become increasingly stressed by at least three independent factors: rising temperatures, ocean acidification, and ocean deoxygenation will cause substantial changes in the physical, chemical, and biological environment, which will then affect the ocean's biogeochemical cycles and ecosystems in ways that we are only beginning to fathom. So, worse than previously expected. Mm, yeah, definitely. Ocean warming, acidification, and deoxygenation are virtually irreversible on the human timescale. This is because the primary driver for
Excuse me.
all three stressors, i.e., the emission of CO2 into the atmosphere, will cause global changes that will be with us for many hundreds, if not thousands, of years. Wow. Other marine ecologists have described ocean warming, acidification, and oxygen loss as a deadly trio because when they have occurred together in the past, mass extinction of animal and plant life have followed. We will consider the elements of the deadly trio separately, but it is important to bear in mind that they are closely related, have the same causes, and frequently reinforce each other. Whew, that
Yeah,
was
it's
the
pretty heavy.
introduction.
The intro, yep,
Pretty
it's
heavy
three
stuff.
parts. It
That was
is
just
hard.
the
You
intro.
just and the chat's
No, this is a great
enjoying this.
article.
I think
Yeah,
everybody's getting into this because it's really interesting material. Thank you guys for being here
yeah.
with us. Okay, where are we?
Sure. Are we ready? Are we
Part
ready
one.
for part one, corrosive
Yep,
seas?
we
Okay.
are.
Okay,
You
guys,
guys
here
all
we go.
ready?
Part one, corrosive seas. Ocean acidification is a slow but accelerating impact that will overshadow all the oil spills that have ever occurred
Oh my
put
god.
together.
Oh my god.
Quote by Sylvia Earle. Ocean acidification has been called global warming's equally evil twin. Both are caused by radical increase in atmospheric CO2, and both are undermining Earth's life support systems. There is always a constant interchange of gas molecules across the air sea interface between atmosphere and ocean. CO2 from the air dissolves in the water. CO2 from the water bubbles into the air. Until recently, the two flows were roughly balanced. The amount of carbon dioxide in each element has not changed much for hundreds of thousands of years. But now, when the atmospheric CO2 has already risen 50%, the flow is out of balance. More carbon dioxide is entering the sea than leaving it. That's been good news for the climate. The ocean has absorbed about 25% of anthropogenic CO2 emissions and over 90% of the additional solar heat, half of that since 1997. If it hadn't done so, global warming would already have reached catastrophic levels. As Rachel Carson wrote years ago, for the globe as a whole, the ocean is a great regulator, the great stabilizer of temperatures. Without
Yes.
the ocean, our world would be visited by unthinkably harsh extremes of temperature. But there is a price to be paid for that service. Adding CO2 is changing the ocean's chemistry. The
Wow.
formula is very simple: H2O, water, plus CO2, carbon dioxide,
Oops.
equals H2CO3, carbonic acid. So that's a perfect little acidification equation right
Yeah,
there.
there it is.
Water plus carbon dioxide
Okay.
makes carbonic acid.
Oh my
Adding
God.
CO2 makes seawater more acidic. Over the past century, the ocean's pH levels has fallen from 8.2 to 8.1. That doesn't sound like much, but pH scale is logarithmic, so a drop of 0.1 means that the oceans are now about 30% more acidic than they used to be. That's a global average. The top 250 meters or so are generally more acidic than the deeps, and acidification is more severe in high latitudes because CO2 dissolves more easily in cold water.
Yeah,
Think of that.
that's interesting.
It is. The present rate of
Hmm.
acidification is hundreds of times faster than any natural change in the last 55 million years. If it continues, ocean acidity will reach 3 times the pre industrial level by the end of the century. Impact.
So think of
Surprise.
swimming around in that.
Yeah.
Think of being the swimmer. Oh God.
Well, think
It's
of being a poor little clam and not being able to make your shell because you can't
yeah.
precipitate the calcium
Yeah,
because it's too
because
acidic to
yep,
precipitate the calcium.
burns up. Oh. It's like
Surprisingly, given the scientific concern
mm,
about CO2 emissions started in the 1950s, little attention was paid to ocean acidification until recently. It was first named and described in a brief article in Nature in September 2003. That's not very long ago. And first discussed in detail in a 2005 Royal Society report that concluded acidification would soon go beyond the range of current natural variability and probably to a level not experienced for at least hundreds of thousands of years and possibly much
wow.
longer.
Hmm.
Right. Those wake up calls triggered the launch of hundreds of research projects seeking to quantify acidification more precisely and to determine its effects. They're still learning about it at this time.
At this time.
Well, at not that time, when they were discovering it.
Hmm.
While
I'm
there
learning
are
about it
still,
as I read it. This is to me. This is. I think it's well written and really understandable. I hope everybody out there that's paying it, that's really watching it, is listening because this is good.
while there are still big gaps in scientific knowledge, there is now no doubt that ocean acidification
Where am
is a
I?
major threat to the stability of the Earth system, one that is pushing towards the sixth mass extinction of life on our planet. Though formally
Wow.
correct, the word acidification is misleading since the oceans are actually slightly alkaline and the shift now underway only makes them a little less so. In the midst of the extreme scenario, 1,000 liters of seawater would still contain less carbonic acid than a small glass of cola. However, just as raising atmospheric concentration of carbon dioxide to 0.041% is causing global climate change, so a small increase in the amount of CO2 in seawater poses major threats to organisms that live in water. Reduced pH has already significantly changed the habitats that marine plants and animals depend on. A further reduction could be deadly for many of them, like the clams and all those. The
Yeah.
most studied casualties of ocean acidification are calcifiers, the many organisms that make carbonate from the surrounding water to build their shells and skeletons, as we mentioned. In seawater, carbonic acid quickly combines with the available carbonate, making it unavailable for shell and skeleton building. Water with less than certain concentration of carbonate becomes corrosive, and existing shells and skeletons start to dissolve.
Oh God.
As marine conservation
So sad.
biologist I'm so sad. Callum
It
Roberts
is,
writes,
Jennifer. Yeah,
it's so sad.
but we're
Lower
learning about it,
pH,
and we're not clueless people.
right.
We understand.
Lower Lower pH is already weakening coral reefs, and the
I've
problem will get
lost.
much worse if CO2 emissions aren't radically reduced soon. The skeletons of coral on Australia's Great Barrier Reef have weakened measurably in the last 25 years and now will contain 14% less carbonate by volume than they did before. Ocean acidification has been dubbed osteoporosis for reefs because of this skeletal weakening. If carbon dioxide in the atmosphere doubles from its current level, all the world's coral reefs will shift from a state of construction to erosion. They will literally begin to crumble and dissolve as erosion and dissolution of carbonate outpaces deposition. What is most worrying is that this level of carbon dioxide will be reached by 2100 under a low emission scenario of the Intergovernmental Panel on Climate Change. So that's already too low of an estimate. About 25% of all fish depend on coral reefs for food and shelter from predators. So the shift that Roberts describes would be disastrous for marine biodiversity. Other calcifiers weakened by ocean acidification include oysters, mussels, crabs, and starfish. Of particular concern are tiny shelled animals near the bottom of the food chain. If their numbers decline, many fish and marine mammals will starve. In particular, and they talk about the different things that are going to starve. And I think in the interest of time, I'll skip all the things that are going
Yeah,
to
because
starve.
aren't we? We're it's once again we're the bringers of the such good news, but the wake up
Right.
call, the wake up call.
We are actually almost through
Yeah,
part one.
yeah, but it's good
So
stuff. I think this
yeah,
was an
let's,
educational newsletter. Yeah,
yeah,
go
let's
for it.
hang
What do
with
you
it.
hang
Yeah,
with
let's
it?
hang with it. I'm
Yeah,
almost done.
it's good stuff. All right, go for it.
Interference with shell and skeletons formation may not be the most deadly effect of ocean acidification. The metabolic
Where am
systems
I?
of all organisms found best when the pH levels of their internal fluids stayed within a narrow range. This is particularly problematic for marine animals, including fish, whose blood pH tends to match the surrounding water. For some species, even a small reduction in blood pH can cause severe health and reproduction problems, even death. A growing body of research suggests that ocean acidification alone will decimate some species of fish in this century, causing the collapse of major fisheries. Only long term studies can determine exactly how acidification will affect global fish populations, but waiting for certainty is dangerous because once acidification occurs, we are all stuck with it. A recent study confirmed that once the ocean is severely affected by high CO2, it is virtually impossible to undo these alterations on a human generation timescale.
Damn.
Even if some unknown and probably impossible geoengineering system rapidly returns atmospheric CO2 to pre industrial levels, a substantial legacy of anthropogenic CO2 emissions would persist in the oceans far into the future.
Jeez.
Holy macaroni.
Holy,
Not good.
holy
Not
macaroni.
good. Warnings ignored. This is the last section of part
Yep.
one. Hang in with us, guys.
Oh yeah, I
In
knew this was going to be
2008,
good.
155 scientists from 26 countries signed a declaration based on irrefutable scientific findings about recent rapid changes in ocean chemistry and their potential within decades to severely affect marine organisms, food webs, biodiversity, and fisheries. To avoid severe and widespread damages, all of which are ultimately driven by increasing concentrations of atmospheric carbon dioxide, we call for policymakers to act quickly to incorporate these concerns into plans to stabilize atmospheric CO2 at a safe level to avoid not only dangerous climate change but also dangerous ocean acidification. Policymakers need to realize that ocean acidification is not a peripheral issue. It is the other CO2 problem that must be grappled with alongside climate
Absolutely.
change. Yeah. In this double threat caused by our dependency on fossil fuels, it is the challenge of the century. I would say the challenge of the
Ma-
1,000-year period.
Yeah. The challenge of the
Or
planet.
more,
The challenge
the
of the
challenge.
planet
Yeah,
of all
exactly.
time.
In 2009, we're almost there, guys. Hang with me. In 2009, 29 leading Earth system scientists identified the level of ocean acidification as one of 9 planetary boundaries.
Boundaries.
That is non-negotiable planetary precondition that humanity needs to respect in order to avoid the risk of deleterious or even catastrophic environmental change at continental to global scales. That's a pretty serious warning right there.
Mm-hmm.
In
This is not
2013, the always
alarmism, folks.
cautious, not alarmism. And in 2013, the always cautious Intergovernmental Panel on Climate Change, IPCC, expressed high confidence that absorption of carbon dioxide is fundamentally changing ocean carbonate chemistry in all subregions, particularly at the high latitudes. Quote, warming temperatures and declining pH and carbonate ion concentrations represent risks to productivity of fisheries and aquaculture and the security of regional livelihoods, given the direct and indirect effects of these variable and physiological processes, i.e., skeleton formation, gas exchange, reproduction, growth, and neural functions. Ecosystem processes, i.e., primary productivity, reef building, and erosion. The IPCC special report on the ocean and cryosphere, published in 2019, concludes that the ocean is continuing to acidify in response to ongoing ocean carbon uptake, that it is very likely that over 95% of the near surface ocean has already been affected, and the survival of some keystone ecosystems are at risk, i.e., coral reefs. Despite overwhelming scientific evidence that acidification is a major threat to the world's largest ecosystems, the governments of the world's richest countries remain silent. Silence is compliance,
See
right,
no
guys?
evil. Silence is compliance. There you go.
The word ocean only appeared once in their Paris Agreement, and acidification wasn't mentioned at all.
It wasn't at all?
Yeah, I guess
I
not.
don't I guess
It
I don't
remains
remember
to be
this.
seen whether the next UN climate change conference, which has been postponed to
Shit.
December 2021, will respond appropriately,
Holy
if
shit.
respond at all. That is it. This is a kicker.
Wow.
This is
This
a
is good.
kicker.
It is a
Wow.
kicker.
This is
And part two,
that.
and there's a part
Yeah.
two. So let's talk about this for a second. David says the alarms have been going off for decades, but somebody keeps hitting the snooze button. David, that's good. But this was heavy, and it's heavy. But this I like this publication. They write it's understandable. It's a teaching publication. I really like it. And there's a part two. We have been 32 minutes, so I think we're going to cover it tonight. I think we're going to cover it, and we're just saying hi to Kim. Thank you for modding, and Rich, Diana, and Human, and everybody's with us, like David, everybody. So let's keep going. I am going to go on to the second part. Now, the second part is Very cool. Also, and let's see how long it is and how long I can sit without moving around and driving you guys crazy.
I can
Uh,
help you also.
okay. All right. That sounds perfect. This one is the second part. Now, the third part's going to come out in October sometime this month. So we're going to bring it back and we're going to cover it for you as our only we can, the news. Climate and capitalism. This is the triple crisis in the Anthropocene ocean. Part two, running low on oxygen. So this is the continuation of the Ian Angus's examination of the deadly trio of CO2 driven assaults on the ocean. And the ocean is losing its breath, kind of like, I won't say. So there is this graphic that shows the open ocean, coastal regions, and the correlation red dots mark the dead zones where oxygen has plummeted to 2 milligrams per liter or less. The oceans need oxygen, guys. I mean, this is stuff nobody talks about because people are just not, they don't care that this is happening. They're going to just keep developing and developing and developing. They don't care. Oxygen deoxygenation is a third but less reported member of an evil climate change trinity, along with global warming and ocean acidification. It is not so much another shoe dropping out of our CO2 emissions as it is a large boot-kicking ocean ecosystem with significant knock-on impacts for hundreds of millions of people who depend on the oceans for a living, and with feedbacks on climate. And that's from Skeptical Science, which I use that in, we use that in our live streams, both of us. I use them. They're a good publication as well. The ocean is losing its breath with deadly effects on marine life and biogeochemical cycles that shape the entire biosphere. Since 1960, low oxygen areas in the open ocean have expanded by 4.5 million square kilometers, an area the size of the European Union. Think of that. I mean, that's like, choking ocean, dying ocean. Some regions have lost 40% of their oxygen, and the volume of water containing zero oxygen has more than quadrupled. The ocean's losing about 1 billion metric tons of oxygen every year. And at present rates, the decline in life-giving ocean oxygen, it'll triple by, there's that number, 2100. Add to that the rapidly growing number of coastal dead zones, and we've got a life support emergency. What do you think of that, Jen? Oxygen. What's going on? COVID. People are choking. They're not getting their breath. Well, the ocean feels like that. The ocean has COVID. The ocean can't breathe. Let's continue. This is compelling as hell. So the oxygen content has fallen just 2%, but decline has occurred almost entirely in parts of the ocean where marine life is usually most abundant. So its impact is far greater than the percentage suggests. Previous articles in this extended series on metabolic rifts have examined two ecological gluts created by capitalism's inherent drive to expand at all costs. The nitrogen glut created by industrial agriculture's dependence on synthetic chemical fertilizers, and the carbon dioxide glut created by capitalism's dependence on fossil fuels. Both are disrupting biogeochemical cycles that have shaped the biosphere for hundreds of millions of years, causing unprecedented rifts in the Earth's system's metabolism. The oxygen crisis is driven by the nitrogen and carbon dioxide gluts in different parts of the ocean. Jennifer, that's heavy. I mean, I know that I get
It
astounded
is.
by everything I read, but as you're learning, you're reading, you're opening your mind to this stuff, and then you're gonna go like you see your neighbor, and you know that they don't know anything about anything, and you do. What do you do with it? I guess we handle it. We handle it, and that's what we're
Mhm.
doing with you guys. Everybody that's with us, we're handling it together. So this crisis, this oxygen crisis, is driven by uh, nitrogen and carbon dioxide gluts in the different parts of the ocean. All right. So this article focuses on the parallel development that has only been studied for the past 15 or so years, that growth of hypoxic, which is low oxygen, and anoxic, zero oxygen area. So remember those, hypoxic and anoxic. I'm sure Jim Massa has taught a class on that on his page, on his channel. Um, so I want to go down to, because we know that what they're talking about, that the synthetic, all those millions of tons of synthetic nitrogen fertilizer, rivers, I mean, what we've been doing forever. So I'm going down to all the oxygen dissolved in the seawater, no matter how deep, originated at or near the surface in one or two processes. There is a constant exchange of oxygen molecules, which is the O2, between the atmosphere and the ocean at the air surface interface. In simple terms, the O2 from the air dissolves in the water, and the O2 from water bubbles into the air. So, considerably more O2 is produced by plants, especially phytoplankton, that grow on and in the water. Photosynthesis requires sunlight, and even in very clear water, the light penetrates less than 200 meters down. That euphotic zone, is the Greek word for well lit, is the origin of nearly half of the world's oxygen and most of the ocean supply. In most of the ocean, the upper 200 meters is called the surface or mixed layer. Waves, wind driven currents, and convection constantly stir its contents, making its temperature, salinity, and dissolved gas content roughly uniform. Now, dissolved oxygen spreads through that mixed layer relatively quickly and easily. That mixed layer is warmed directly by sunlight and is constantly replenished by fresh water from rivers, rain, and melting ice. So it is lighter, less dense than the water below it, where a sudden temperature drop defines the thermocline, which is a colder and denser layer that separates the mixed layer from the cold and the very slow moving deep layer that comprises about 90% of the ocean's volume and mass. You with me, guys? The thickness of the thermocline varies with seasons and latitude. So in the polar seas, it and that mixed layer scarcely exists, but in most of the ocean, it extends from 200 to 100 meters below the surface. I just want to take a break for a second, Jennifer. Just, I'm visualizing. You're visualizing this,
Mhm.
the ocean down there, and the everything is what, by columns. I don't know what the measurement. This was the measurement here in this graph picture. It said it is, I want to try to make it bigger, but I don't know if it's going to work. Depth in meters, and it was talking about the typical ocean layers, and the temperature falls rapidly in the thermocline between the mixed layer above and the deep layer below, where temperature is nearly constant. And then the depths vary by latitude and season. I feel like I just took a science class. I do. Um, all right, so where are we, guys? Are you enjoying this? Because I am, so I'm going to keep going too. This we're learning about this process. They call it's the ventilation, and it moves some of the mixed water and the oxygen it contains into that thermocline. The distribution of oxygen depends on local, regional, and global currents and tides and local topography, unpredictable turbulence, and other factors. So it's uneven. Most notably in some parts of the thermocline, a combination of weak ventilation and oxygen consuming microorganisms results in pockets called oxygen minimum zones. Most of the thermocline at that depth is teeming with fish, but life in an OMZ is largely limited to microbes that can survive with very little or no O2. So I wonder, Jennifer, will that be what survives the apocalypse and the collapse? Are those
Yeah,
microorganisms? Wow.
probably. That and cockroaches.
Yeah, right? Cockroaches. Boy, I don't even want to think about cockroaches. I can think of some cockroaches that are in the Senate. In the United States Senate. Typical, terribly cockroachish people. So, where are we? We have been talking about the distribution of oxygen. I'm going to go down and I'm just going to go over really quickly this the way they talk about the slower process plays a major role in distributing the oxygen in the deep ocean. When the water freezes in the North Atlantic, it leaves the salt behind, creating a layer of dense brine that sinks to the bottom and slowly moves south, bringing along any oxygen it absorbed at the surface. Thus begins that global conveyor belt, that slow, deep sea current that carries almost, wow, 20 million cubic meters of water per second, Jennifer. 100 times more
Amazing.
than the Amazon River. And it distributes that oxygen and nutrients through that deep ocean. So that takes a lot. That's a lot of energy. Distributing this oxygen and nutrients. Let's see what this graph. It's the Great Conveyor Belt, and it's small, guys. I know it's small, but that's what it looks like. The way that the water is, and how the oxygen flows through it. This is what doctors study when they study your body. And the planet is like a body. It has veins, and it has parts. It's just the planet body. People, it's all similar. Learning these principles and how things work. It's all similar in learning. Animals, uh, the ocean. It's amazing how we've developed in all of these beings have developed, how they grew, all that. It's just fascinating. So my mind is on amoebas, uh, I'm going to go down to the climate change versus oxygen. And as we saw in part one that Jennifer read, ocean acidification is a direct result of skyrocketing CO2 emissions. Right there. And oxygen deoxygenation has the same cause. Greenhouse gases are heating the world, and over 90% of that additional heat has been absorbed by the surface layer of the ocean, reducing the ocean's total oxygen and expanding oxygen minimum zones. So there's the research is going on, and they're talking about the three temperature dependent processes: solubility, stratification and circulation, and metabolic rates, which I'm not going to go into. You guys that want to look at the article, in the interest of time, I'm going to skip those, but I am going to go to the consequences, which is oxygen is fundamental to life in the oceans. The decline in ocean oxygen ranks among the most serious effects of human activities on the Earth's environment. Aren't these little boxes, aren't those like the little kickers of these articles? These little boxes that are
Mm-hmm.
like, they're gotcha by quotes by these people that are working in the field. Holy crap. So I'll go over quickly. An ocean anoxic event is the period where the level of dissolved oxygen in a large part of the ocean plunges to or near zero. And it's happened many times in Earth's history. Most recently, about maybe 94 million years ago, with the loss of oxygen wiped out a large proportion of marine life. And as scientists associated with Woods Hole, everybody knows Woods Hole, Oceanographic Institute point out, ocean conditions today are similar to those that prevailed before the crisis, and they're rapidly getting worse. Well, what are they getting worse from, Jennifer? It's man made. I mean, it might not be a
Mm-hmm.
natural occurrence. This is obviously man made. Uh, It says the vast body of evidence from temperate marine ecosystems and a few studies from tropical marine ecosystems demonstrate that hypoxia stress often results in catastrophic ecosystem simplification through loss of biodiversity, trophic complexity, and fisheries. So basically, in the ocean, because of these issues, Jennifer, we're losing. We're going to lose. The oxygen is depleted. The end of the article really says it's important to bear in mind that oxygen depletion does not happen in isolation. And for
I'd like
example,
to point out that
yes,
the jellyfish, it's going to be a freaking, you said what was going to survive, and I joked the cockroaches. I'd like to take that back. It's
okay,
going to be the microbes and the jellyfish.
is that in
So
the article
jellyfish
there?
don't need, yep, next paragraph.
There it
Jellyfish don't
is.
need hardly any oxygen at all, and they're getting huger and huger
Oh, they are.
and more plentiful. It's like a jellyfish apocalypse.
Actually, I've read about that. Yeah, I have read about that.
Mm.
Sorry, I mixed that. I missed that. I missed that paragraph.
You hadn't got there yet.
Oh,
You hadn't
well,
got there yet.
yay, you picked it up. Do you want to go on with this? I thought did I go through this, or did I lose myself
No,
because I was
you
imagining all
lost
these?
yourself.
I lost myself. Okay, you're gonna tell me where we are because I was in the ocean and I
Do you want
was
me to
yeah.
do you want me to
I
pick it
thought
up?
we were
In
almost
fact, any
finished.
reduction in available oxygen, not just hypoxia, is problematic for most ocean life.
Okay.
Although some marine animals, jellyfish for example, like we just talked about, are little affected by oxygen reduction, others go into decline when the level falls even slightly. As a result, the population balance in areas where oxygen levels are falling tilts quickly towards hypoxia tolerant species like jellyfish.
Like
Others
jellyfish.
flee or die, as well as directly threatening the lives and habitats of marine organisms. Oxygen depletion is disrupting the global nitrogen cycle. For hundreds of millions of years, naturally occurring oxygen minimum zones have played a key role in the nitrogen cycle because the bacteria that convert reactive nitrogen compounds into inert nitrogen gas are triggered to do so only in the absence of oxygen. The expanse of OMZs means that growing numbers of microbes are removing reactive nitrogen from the ocean, unbalancing the cycle and reducing the availability of essential nutrients for marine life. What's more, when bacteria convert to NR or N1 or N2 in the presence of small amounts of oxygen, that's the case in most parts of the OMZs. They also produce nitrous oxide. This is the key, guys. Nitrous oxide, a greenhouse gas that is 300 times more powerful than carbon dioxide. This whole thing is going to go. I think so.
Okay,
I
I was
think so.
muted. So that nitrous
Oh,
oxide
yeah.
is that laughing gas?
I don't know. It might be.
I thought it was. I don't know, a
So at
little
least we'll be
factoid.
happy while we're going into like,
Oh gosh, in a
crisis.
hypoxic state.
Um, yeah, but this stuff also depletes the ozone layer. Multiple studies have found large amounts of N2O, nitrous oxide, rising from the ocean surface above OMZs. This is a classic positive feedback. Global warming accelerates the production of nitrous oxide, which in turn accelerates global warming. Vicious cycle. Finally, it is important to bear in mind that oxygen depletion does not happen in isolation. For example, organisms that consume more oxygen also increase acidification by exhaling more carbon dioxide. The fish trying to escape oxygen-starved waters
Mm.
find that alternative locations are too acidic. Part 3, coming next month, of this article will examine the third component of the deadly trio, ocean
That's cool.
warming. As we've seen, higher water temperatures contribute to acidification and deoxygenation, but they also play a direct role in the destruction of marine systems.
Yeah. Wow. These
What can you say?
these were good. I'd say
Yeah.
these were really both very good. I look forward to the third in the series. How are you doing in the chat, guys? David Alcock, um, who's going to have a video that we're going to share that he's making. He looked at the Antarctic ozone hole the other day on cams, and it looks bad. Mm,
Does it?
yeah, David's
It's
very
back.
knowledgeable. It's bad. David's really knowledgeable though. Hi,
Yeah.
Anthony, and Hoople's cat's with us from Canada. He says MAGA, making America uh, anoic again. Apneon, wait, apnoic. Okay, what's wrong with me? Can you pronounce that one? APN, is this
I have no idea.
APN? Me neither. Wow. Well, let's go to Basil. Hoops, you'll tell us. Maybe it's a nursing term because he's an RN and he's
Yeah.
working in the hospital. He works in the hospital. Basil says we're laughing our way to extinction. Well, what are we gonna do? Cry? Or are we gonna try to get through? I mean, we have we have hurdles that we pass every single day, right, Jennifer? All of us do. But
Yeah.
being able to understand. Hey, like David Alcock says, he's a clued up moron. Okay, you're not a clueless moron. He's a clued up, Jennifer. He's a clued up moron. Oh my gosh, wow. But
Well,
what
I
do you think?
think that in the interest of time, since it's
Yes, ma'am.
56 after the hour, we have
Oh,
to
okay.
just jam through this next one and
Yeah.
then call it a night. So,
Okay.
this is also about the oceans. This was
Yes, it
in Science
is.
Alert recently, and it's about the blob, and that's the thing that's in back of
Dun,
us.
dun, dun,
So,
dun. The
hang with me,
blob.
guys. Hang with me, guys. The massive blob anomaly has our fingerprints all over it, study finds. This just came out on the 24th of September, 2020. And probably a lot of you remember the blob that was back in the oceans in 2013. In 2013, a suffocatingly hot blob of water brewed in the Pacific Ocean off the coast of North America. It decimated marine life.
Why do I have?
Thousands of seabirds washed up dead on shores along with starving baby sea lions. Really
This is a
sad.
horrible
Salmon,
article.
krill, and other marine animals vanished as the warmth fueled a massive toxic algal bloom that also shut down crab fisheries. Confused summer breeding fish spawned during winter, while lost subtropical species such as swordfish and pyrosomes appeared far outside their normal range. Over 100 million Pacific cod are thought to have perished. At its peak, parts of this blob reached almost 4 degrees centigrade above normal water temperatures in the anomalous pocket of heat, persisted until 2015. So for 2 years, that hot blob was there persisting. Since then, more monstrous hot water blobs have formed in oceans around the world, wreaking havoc on ecosystems and fisheries and setting back decades of effort to save species like humpback whales, whose populations plummeted by 30%. These marine heat waves have also caused mass coral bleaching, melting sea ice, and the release of carbon dioxide from dying seagrass. New evidence suggests that the intensity of these events isn't just fueled by climate change, it's making the very occurrence of blobs more likely too. Environmental physicist
Blobs.
Charlotte Lofkater from the University of Bern in Switzerland and colleagues studied the marine heat waves recorded between 1981 and 2017. They found the 300 largest events lasted an average of 40 days, covering an average of 1.5 million square kilometers and
Wow.
had a peak temperature of 5 degrees centigrade hotter than
Wow.
normal.
She'd be an interesting one
Focusing
to
on the
talk to.
seven, yeah,
Charlotte.
focusing on the seven largest, most recent blobs, the researchers calculated how likely each would have been with or without current global warming. Their analysis, which used conservative estimates of risk attributions, found impactful marine heat waves are now over 20 times more likely because of human-induced climate change. Their frequency, duration, intensity, and cumulative intensity of large.
Uh-oh. I lose you? Oh, wait a second. What happened? Oh, guys. Did we lose Jennifer? Jennifer, did you freeze? I think we lost Jennifer. So let's see what's going on. I'll get her back. Okay. Let's get Jennifer. Do you guys, there's a poor network connection because we're getting a storm. Oh, shit. Oh, shitski. I can't get her at the moment. Let me try it again. Hang in here with us. If not, guys, we'll have to say goodbye. Let me try again if you wait, because you know what? While we're doing this, I'm going to play you something. I'm going to play you a video, and I'm going to get her back. It's a video that I downloaded on the permafrost that's happening in Siberia, so enjoy.
Climate change has been causing all kinds of problems here. Where we're driving now was completely flat. 20 years ago, there was actually an airport here, and this was the runway. But because the permafrost has been thawing, the ground has fallen away. The result? No more planes here now.
Now we stay in 12 meters on the surface.
This is the permafrost, yeah?
Yes, it's permafrost. You see this layer, it's enriched the organic matter, the shrubs, grass,
And what happens when the permafrost thaws?
Organic matter contains a lot of gases, greenhouse gases, and when permafrost thawing, they can go into air.
So the more the permafrost thaws, the more gases go into the atmosphere, yeah?
Absolutely right.
Говорят, что глобальное потепление начинается. Вот если так, не знаю, что будет. Это пускай это дети будет подумают. У меня это уже прошло, наверное.
Well, I lost Jennifer, and I have called her back on Skype, and I cannot. It says she's offline now, and I don't understand it. So I guess we'll say goodnight. I have an ending video that I played the other day, and it was about this. It was a billionaire climate change denier, and I might end with that, but I don't know where Jen is. So if you bear with me, I will just see if she's answered me. Nope, she hasn't. It's like she just left. I have no idea what happened. I don't know. I'm going to call again one more time on Skype, and while you guys are with me. You're pretty busy in the chat. There's quite a few of you with us. So let me try again and see if I can reconnect, because I would love to have Jennifer back to say goodnight. But if not, well, I'll just do a little chit-chatting with you guys and say goodnight. Nope, it says she isn't online. I wonder what happened there. Oh my goodness. All right, well, I'm going to end with a video, and I'm going to say hi to Suzanne. How are you? I'm so glad that you joined us. Hi, hi, Sam. Let's see what's going on with all of you. Thank you, Hooples. Night to you. I don't know. She hasn't even answered me on the messenger thing. I don't know. Well, Going South has something going on. Let me see if he put it up. He's got something after this show. Where is it? What do you have on? Let me see if I missed it. Going South. Well, check them out. Going South somewhere has a show on after this. And let's see. Collapse Chronicle. If nobody has mentioned it already, the new David Attenborough We Are So Fucked doc just came out on Netflix. Go check it out. I am sure you can get a free trial if you're not a member. All right, well, maybe I'll watch that with my headphones on tonight. Let's see, how long have we been? Okay. All right, well, let's... I don't know where all the Facebook people are. Oh, wait, Heidi's here. Heidi, Wendy, hi Wendy, thank you. Good night. Not enough bandwidth. That might be my problem. I don't know. It didn't kick me. It didn't even say I had the less. Yes, it's looking like even Attenborough is getting ready to throw in the towel. These are some good comments, because all the best to everyone. All right. I don't know. Should I end with my goofy video or just let you all go? It's been 1 minute. It was the video from the other day, and it was about this. I'll end with it. What the hell? You can all watch it. Good night, and I hope I can find my Jennifer. Peace out, guys. Good night. You can laugh at this.
Okay.
I got a few, Bob, yeah.
Okay. You support Trump?
Yep.
Okay.
I was one of the first public endorsers of President Trump.
What are you guys going to do when our ocean level rises?
Thank you for asking that question. I have the answer now.
Don't let me finish.
I have the answer.
Let me finish.
Now you're full of shit. Sit down.
I'm going to answer you.
I'm gonna just shut up and sit down.
No, wait.
Sit down.
No.
All right, finish the question,
Our
then
gas
answer.
is changing on Earth, and it's changing to CO2. What do you people with the money, what are you doing about this? Because
I'm gonna tell you right now.
Answer.
No.
Okay. In 2011, my wife and I were in Antarctica, renewing our vows. For most of you that don't know, Antarctica's on a mountaintop. Okay, and there is a $500 million facility, scientific facility there, and the scientists came to give us presentations about global warming. And they had cores of ice that they had drilled. They had drilled 4,000 or 5,000 cores, and they only brought 15 or 20. So they're going through the second or third core, and they said 275,000 years ago, this was the temperature, blah, 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 blah. And then 55,000 years ago, the world was 2 degrees warmer Celsius than it is today. This is 2011. And, oh, wait, stop. And he said, and I said, well, you mean the whole world? He says, yes. And the poles are only benchmarks. And I said, well, what about the things that the young woman alluded to? Okay? And he said, it's all cyclical. And although the gas may have exacerbated it, in the cosmos of time, it's not a fart in the wind. In the cosmos of time, of the 13.8 billion years that we've been on this miserable planet, it's not a fart in the wind. And as I told Joe Rogan on his show, and he said in his infinite wisdom, and Joe, if you hear this, I thank you for the opportunity to be on your show. He said, then in 25,000 years, it's most likely not going to be a problem. Now, my direct answer to your question, if that were really true, which you believe, and let's just for a moment say that it is true. That means that the best scenario vis-a-vis global warming is about 10 feet raise in water. That's the best scenario over the next 40, 50 years. That's the best scenario. The worst scenario is about 100 feet. But let's just take the 10 feet. If the water on the planet is going to rise up 10 feet, that means the southern part of the United States is gone. England is gone. Most of Europe is gone. And I can go, most of Central America is gone. Okay, if that's the case, let's just take Florida, for example, which is one of the fastest growing beachfront condominiums on the planet. In the prospectus, when you invest, there should be, in the footnotes, if global warming is for real, they won't put it that way, global warming happens and water rises 10 feet, this investment you made is fuck all. Not one single investment prospectus written since 2000, this century, has alluded to global warming. Not one motherfucker. If it were really true, the banks wouldn't invest. The banks wouldn't finance. Not one motherfucking condominium. So the people that have the money, because the financial institutions, the banks of this world know it's not going to happen. Otherwise, you couldn't get a goddamn loan in London. You know those 30, 40-year mortgages? The world will be over by then. Is Barclays Bank going to give you a motherfucking loan? With the greatest respect, ma'am, it's the greatest fraud that's been perpetrated on mankind this century.
Well, guess what? Jennifer's here with us to say goodnight. So a lot of people left, but Jennifer, say goodnight.
Hey. Good night, guys.
Tell us actually
My
what
internet
happened.
Completely blurped out.
Wow,
Just
that was
all of a
weird. I
sudden
got
went-
scared.
Oh, no. I'm still here. It just all of a sudden I had no internet for about 5 minutes or so.
Wow, that's pretty.
Minutes.
It was spooky. I was
awful.
like, "Where is she?
I know,
Where
it's
is she?"
kinda
I thought it was
spooky.
me.
Like, what
So,
happened?
all right, guys. Well, do you have anything to say, Jennifer?
No, but I mean,
Interesting stuff.
basically our planet should be not called Earth, it should be called Ocean. And we've had a really deep dive tonight into the ocean systems and how important they are for our life on Earth. So this is just another thing to keep looking at and especially the ocean acidification, which is so very, very important and going up so very fast as well. So, just keep looking at all this stuff and we'll see you next week.
Yeah, see you next week. Thank you. I will play the closing video. Good night, guys. Thank you.